So, good day everyone. Today we will be discussing one of the fundamental concepts of operating system, which is memory partitioning. So, memory partitioning plays an important role in how computer manage and allocate their memory to different processes and sections. So, here's the overview of what we're going to explain today. So, we'll start by defining what is memory partitioning, and then we'll talk about why it matters. So after that, we'll explain or explore the different types of memory partitioning, which is the MVT or variable partitioning and MFT or fixed size partitioning. So by the end of the lesson, you'll understand how these methods impact the system performance and resource management. So what is memory partitioning? So memory partitioning is simply means dividing a computer's memory into separate sections and partitions. So think about like slicing a cake. So each slice or partition can be assigned to different processes or programs. So yeah, then this allows the system to organize and allocate memory more efficiently. So ensuring that each process has its own space needed to execute po. Then it's a fundamental technique of computer science and embedded system because efficient memory use can directly affects the overall performance of the computer. So why does memory partitioning matter? Why is it important? The four main reason is, first one is fragmentation. So proper partitioning means it minimizes the wasted space in memory. And then second is performance. It allows the CPU to quickly access the memory sections, improving speed and reducing delays. Third one is reliability and safety. So by isolating processes in their own partitions, one faulty program won't affect the entire system. And the last one is resource management. It helps the operating system to distribute memory fairly among active programs. Now, let's move on to the two main types of partitioning, which is fixed partitioning and dynamic partitioning.
Now, let's discuss about MFT or multiple fixed partition. So, the first concept of this is that it allocates memory based on fixed partition sizes. This means that the RAM or our memory is divided into a number of fixed size partitions, and each partition can hold exactly one process at a time. And once the size of our partition is set, it doesn't change. For example, let's look at our diagram over here. We have the operating system that is mounted in the RAM. This means that the OS already occupies a part of the memory. After that, the remaining memory is divided into several partitions for user processes. So in this case, we have 4 partitions and each partition is 4 MB. So actually, these partitions can either be the same size, just like in our example, or different sizes such as 2 MB, 4 MB, 8 MB, and so on, depending on how the system designer wants it. Now, whenever we allocate process, it should fit exactly or be smaller than the size of our partition. So if the partition size is 4 MB, the process that we load into it should also be 4 MB or less. This is because in fixed partitioning, memory allocation is contiguous, meaning it must occupy one whole partition. We cannot split a partition or a process between two partitions. Now, there's a disadvantage here. If a process doesn't completely fill up its partition, for example, a 2 MB process in a 4 MB partition, then the 2 MB of space is wasted. So this unused space or wasted space is what we call internal fragmentation. So to summarize everything, the number of partitions is fixed, the size of each partition is fixed, processes are loaded into these partitions as long as they fit. And finally, internal fragmentation can occur if the process size is smaller than the process or partition size. Now, let's move on to the advantages and disadvantages of MFT. So, the advantages of MFT include its simplicity and predictability. Since partition are predefined, there is no external fragmentation rather, and everything is neatly organized as stated here in our slide. However, it also has its disadvantages, which some memory with partition may go unused, as I have mentioned earlier, which is called internal fragmentation. So it it's also less flexible because once the partition are set, you can't adjust their sizes. You cannot easily adjust their sizes. Then lastly, the number of processes that can run is very limited to the number of available partitions.
Here in dynamic partitioning, also known as MVT or multiple variable partitions, it allocates and deallocates memory in a flexible way because based on the name dynamic, the memory is changing and able to adjust for arriving processes. So it allocates memory based on process requirement because when the process arrives, it gets the exact amount of memory, unlike in fixed partitioning where there is a waste space or internal fragmentations. So it is more efficient but harder to manage since there is less waste but harder to manage because you will work on it to find the right space, or the system will work on it to find the right space and keep everything organized. So at first, there is no partitions, only the OS area and free RAM. As you can see here in our presentation, you have your memory and the OS with the free space below. So the OS occupies a fixed block in your memory because your computer will not work if you don't have the space for your operating system. The other space, which is the free memory, it is for the user. So memory is given to processes as they arrive and partitions change as jobs enter and leave. When a process is finished, it will be gone and give free space for other processes. So let's see how the dynamic partitioning works step by step. So at the start, as you can see here in our presentation, the memory is divided into two parts for your OS and for the user. Let's say your memory has 100 KB and let's say your OS occupies the 200 KB. The memory that's left is 800 KB. Let's say P1 arrives with 200 KB. There. The system will make a partition for it and the rest will stay free. Let's say the other process arrives. There. So as you can see here in our presentation, if other process arrives, it do not create internal fragmentations because it adjusts and change. As you can see, you have 100 KB left in your memory. So that's your free space or hole. Let's say that process 2 finishes. As you can see, it made a gap. So the 400 KB space will become free, leaving a gap in the middle, and that we call a hole. So this is how external fragmentation begins. So if the system have new arriving processes, it will try to fit them into free spaces using algorithms like first fit, best fit, and worst fit. So in advantages, it is very flexible because partitions adapt, change, and adjust to process sizes. It also reduces internal fragmentation since there is no fixed partition at the start. The disadvantage of dynamic partitioning, it can create external fragmentations, leaving holes or empty spaces everywhere in the memory. It is also more complex to manage because the system will work hard and search for where each process can fit. So overall, dynamic partitioning gives process the right size memory it needs. It is very flexible and efficient, but it's harder to manage because it leaves external fragmentations and free spaces or holes. I hope this helps you understand how it works with its advantage and disadvantages. Let's move on to our final conclusion.
So, to conclude our topic in memory partitioning remains a foundational mechanism in operating system, ensuring that computers' memory is allocated, organized, and utilized efficiently. So, by examining both fixed partitioning or MFT and variable partitioning or MVT, um, we can clearly see how each method impacts the system's performance, flexibility, and resources optimization. MFT provides a straightforward and predictable structure, while the MVT introduces adaptability and supported by dynamic allocation algorithms, which is the first fit, best fit, and the worst fit. So, understanding this concept is very important for recognizing how the modern operating systems maintain their stability. So, it prevent processes interference and maximize available memory. So, effective memory partitioning is key to achieve reliable and high-performing computing environments. So, thank you for listening for our report. God bless po. Oh, God bless. Anong God bless? Putang ina. Ang random.